Morning, girls. Do you remember what we have learned in the last class regarding the introduction of the topic polynomials? What is a polynomial? An expression with a number of terms whose parts are positive exponents is called a polynomial. Remember, children, the parts of the variable in the polynomial should always be positive whole numbers. And coming to the types of polynomials, monomial. A polynomial with one term is called a monomial. A polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial. And all numerical numbers are called as constant polynomials. Coming to the degree of the polynomial, the highest power of the variable in the given polynomial is the degree. Linear polynomial. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. And the degree of the constant polynomial is 0. And the degree of the zero polynomial is not defined. In today's class, children, we shall solve the questions in exercise 2.1. Open your textbooks to page number 32, exercise 2.1. Exercise 2.1. Yes, children, have you all opened your books? The question is, which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. One variable means, children, there should be only one unknown. All x's, all y's, all z, or any other unknown. Second, keep in your mind that the parts of the variable in the polynomial should be a whole number. The parts of the variable should be a whole number. First, Roman number 1. Which of the following expressions are polynomials in one variable and which are not? Give reasons for your answer. I am doing the second question, children. Since the question is in y, girls, you should write as p of y is equal to root 2. The variable is y, so we write it as p of y. And is this a polynomial? P of y is a polynomial because its power is 2, which is a whole number. Yes, P of y is a polynomial. Yes, P of y is a polynomial, and P of y is a polynomial since the power of y is a whole number. The power of y, what is the power of y? 2 is a whole number. Third bit, children, coming to the third question, 3 root t plus root 2. Look at root t. The power is not a whole number. The power is not a whole number. If you write it in power notation, what does it become? 3 t to the power of half plus 2. P of t is equal to 3 root t plus root 2. Therefore, P of t is not a polynomial. P of t is not a polynomial as the power of t is not a whole number. Yes, fourth bit, y plus 2y. When you write 2 by y in power notation, it is y to the power of minus 1. P of y is equal to y plus 2y is not a polynomial. P of y is not a polynomial. Since the powers of t is not a whole number. Since the powers of t is not a whole number. Yes. Question number 2. Second question. Write the coefficients of x square in each of the following. What does the word coefficient mean? It is the numerical number before x square. Coefficient of x square means the numerical number before x square. If it is positive, the coefficient will be positive. If the sign before the variable is minus, the coefficient becomes minus. Question number 2, children. Write the coefficient of x square in each of the following. I am doing the second bit. 2 minus x square plus x cube. Yes. P of x is equal to 2 minus x square plus x cube. What is the number before x square, children? The coefficient. The coefficient of x square. Do you remember? When there is no number, what will be the coefficient? 1. No number, the coefficient is 1. As there is a minus sign, we write it as minus 1. Exercise 2.1, children. Which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. All of you know what are polynomials? An expression in which the parts of the variable are whole numbers. An expression in which the parts of the variables are whole numbers. Question number 1, children. I am going to do second bit. Since the variable is y, you write it as p of y. If your variable is x, you should write it as p of x. If it is z, you write it as p of z. Now your variable here is y and the highest part is 2. Yes, which of the following expressions are polynomials and which are 2? What is the degree of this polynomial? The degree of p of y is equal to 2, which is a whole number. Therefore, p of y is a polynomial. P of y is a polynomial. The parts of the variable should always be whole numbers. Third bit, children. The variable is t. So we take it as p of t. 3 root 2 plus t root 2. Root t means what, children? T to the power of half. T to the power of half. Because the power is not a whole number, the degree, the power of t is not a whole number. The power of t is not a whole number. Therefore, p of t is not a polynomial. P of t is not a polynomial. Yes, coming to the fourth bit, children. The variable is y. P of y is equal to y plus 2 by y. If you write in power notation, what does it become? Y to the power of minus 1. The power of y is not a whole number. The power of y is not a whole number. Therefore, P of y is not a polynomial. P of y is not a polynomial. Fifth bit. It is a polynomial in 3 variables. X power 10 plus y power 3 plus t power 50. Yes, it is a polynomial. It is a polynomial in 3 variables. In 3 variables. What are those 3 variables? X, y and t with positive powers. Are you clear about this, children? Second bit, the degree of P of y is equal to 2. Y power is 2. Therefore, it is a polynomial as 2 is a whole number. Third bit, P of t is equal to 3 root t plus t root 2. Root t means what? T power half. The power of t is not a whole number. Therefore, P of t is not a polynomial. Third one, y plus 2 by y whole power minus 1. The power of p is not a whole number. P of y is not a polynomial. Fifth bit, it is a polynomial in 3 variables x, y and z with positive powers. Second question, write the coefficient of x square in each of the following. 2 plus x square plus x. It is a polynomial in x. What is the term before x, children? 1. The term before x is 1. The term before x square is 1. And because it is, the coefficient of x square is equal to 1. Third bit, children, pi by 2 x square plus x. The polynomial in x is pi by 2 x square plus x. What is the coefficient of x square? The coefficient of x square is equal to, the coefficient of x square is equal to pi by 2. Fourth bit, children, P of x is equal to root 2x minus 1. Your question is coefficient of x square. Do you have x square term in your polynomial? There is no x square term. So, the coefficient of x square is equal to 0. When there is no term in polynomial, its coefficient becomes equal to 0. You have no x square term, so your coefficient is equal to 0. Third question, give one example each of a binomial of degree 35. Third question, girls, give a binomial, one example each of a binomial of degree 35 and a monomial of degree 100. Binomial means how many terms? 2 terms. And the highest power, a binomial of degree 35, 7x to the power of 35 plus 2. There are only 2 terms and the degree of this polynomial is 35 because the highest power of x is equal to 35. Second bit, and a monomial of degree 100. P of x is equal to minus 7 by 9 x to the power of 100. Monomial means only one term. And what is the degree? What is the power of x, children? 100. The degree of P of x is equal to 100. Question number 4. Write the degree of each of the following polynomials. Write the degree of each of the polynomials. I think you know what does the word degree mean? Taking the term with the highest power. Fourth one, first bit. It is a polynomial in x. And the highest power of x is what? 3. So what is the degree of P of x? P of x, the degree of P of x is equal to 3. Second one, the polynomial is in y. So the degree of P of y, the highest power is what? 2. So the degree of P of y is equal to 2. Third one, the variable here is t. And the highest power of t is 1. The degree of P of t is equal to 1. Fourth bit, children, 3. You know what is 3? A constant polynomial. Do you remember the degree of the constant polynomial? The degree of the constant polynomial is 0. Fifth question. Classify the following as linear, quadratic and cubic polynomials. Do you know what is a linear polynomial? A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. Zeros of a polynomial. Zeros of a polynomial. Zeros of a polynomial. Zero of the polynomial means, children, zero of a polynomial. A zero of a polynomial. A zero of a polynomial means solving the polynomial equation, solving the polynomial equation, solving the polynomial equation at P of x is equal to 0. A simple concept, nothing to get confused. A zero of the polynomial means your given polynomial is equal to 0 and solve for x. I shall repeat, children. Zero of the polynomial means your polynomial should be equated to 0 and solve for x. Equate your polynomial to 0 and solve for x. X is a linear polynomial, then x has only one solution. X has only one solution. X has only one solution. If P of x is a linear polynomial, then x has only one solution, children. P of x is equal to 7x plus 9. P of x, zeros of the polynomial means P of x is equal to 0. Therefore, 7x plus 9 is equal to 0. 7x. What will happen to 9 when it goes to other side? Minus 9, which is equal to only one solution. Second one. P of x can have P of x can have more than one. P of x can have more than one solution or zeros of solution. P of x can have more than one solution. P of x is equal to x squared minus 9. P of x is equal to 0. Therefore, x squared minus 9 is equal to 0. X squared is equal to 9. What is the part, children? 2. Because it is 2, what does it indicate? Square root. What is square root of 9? The square root of 9 is equal to plus or minus 3. Therefore, the zeros of P of x is equal to 3 comma minus 3. P of x can have more than one solution. If it is a linear polynomial, it has only one solution, children. Sometimes the P of x can have more than one solution when x square is a perfect square. To minus 3 by 5, the zeros of P of x is equal to minus 3 by 5. Zeros of the polynomial means your polynomial equal to 0 and solve for x. A polynomial can have 0 as the solution, any rational number as a solution, or it can have more than one solution when x squared is a perfect square. Page number 34, exercise 2.2. Roman number 4. Find the zero of the polynomial in each of the following cases. Find the zero of the polynomial in each of the cases. Zero of the polynomial means, children, polynomial is equal to 0. Therefore, x minus 5 is equal to 0, x is equal to 5. The zeros of P of x is equal to 5. Polynomial equal to 0. Fifth bit, children. P of x is equal to 3x. P of x is equal to 0. 3x is equal to 0. X is equal to 0 by 3, that is equal to 0. The zeros of P of x is equal to 0. Yes. Sixth bit, girls. P of x is equal to ax. P of x is equal to 0. Ax is equal to 0. X is equal to 0 by a, that is equal to 0. Therefore, the zeros of P of x is equal to 0. Seventh bit. P of x is equal to cx plus d. P of x is equal to 0. Cx plus d is equal to 0. Take d to the right side. X is equal to minus d by c. The zeros of P of x is equal to minus d by c. Zeros of the polynomial means polynomial equal to 0. Your polynomial is x minus 5. X minus 5 is equal to 0. Solve for x. The zeros of P of x is equal to 5. P of x is equal to 3x. P of x is equal to 0. 3x is equal to 0. X is equal to 0 by 3 is equal to 0. the zeros of P of x is equal to 0. Sixth bit, P of x is equal to AX. Polynomial equal to 0. AX is equal to 0. X is equal to 0 by A equal to 0. The seventh bit, children, P of x is equal to Cx plus D. The polynomial equal to 0. Therefore, Cx plus D is equal to 0. Cx is equal to minus D. X is equal to minus D by C. The zeros of P of x is equal to minus D by C. First question. Find the value of the polynomial. Find the value of the polynomial. Find the value of the polynomial 5x square minus 5x minus 4x square plus 3 at third bit x is equal to 2. A polynomial is given and you are given a value for x, children. Since your variable is x, write P of x is equal to 5x minus 4x square plus 3. Your x is equal to 2. So put P of 2. 5x means 5 into 2. 4x square, 2 the whole square. 5 2s are 10. 2 2s are 4. 4 4s are 16 plus 3. Positive numbers together, negative numbers together. One term positive, one term negative, subtract and put the sign of the greater number.
15 minus 16, how much?
Second sum, children. Given the polynomials, you are asked to evaluate P of 0, P of 1, P of 2. I am doing the second bit, girls. I am doing the fourth bit. P of x is equal to x minus 1 into x plus 1. The first value is P of 0. In the place of x, put minus 0. Your x is 0. 0 minus 1. 0 plus 1. Minus into plus minus. Second value is P of 1. 1 minus 1 into 1 plus 1. What is 1 minus 1? 0. 1 plus 1, 2. 0 into 2 is equal to 0. Third bit. The third one value is P of 2. P of 2. P of 2. The third value, girls, is P of 2. Two minus 1 into 2 plus 1. What is 2 minus 1? 1. 2 plus 1, 3. 1 into 3 is 3. These are the values for P of 0. P of 0 is minus 1. P of 1 is 0. P of 2 is equal to 3. I think you could follow, girls. Yes. The first one is zeros of the polynomial. The second one is homework. Please note down the homework, children. Page 32. Exercise 2.1. First Roman number. First bit. Second Roman number. 2 4. 3 4. 3 all. 4 all. Fifth Roman number. All. Page number 34. First Roman number, second Roman number, fourth Roman number, all. 1 all, 2 all, 4 all. Children, if you have a doubts, please put your questions in the WhatsApp group so that we'll be able to answer in the next class.